Hello friends, myself Sachin. In this video we are going to discuss about stack and queue implementation using linked list. When we talk about the linked list implementation, then we are talking about dynamic memory allocation. I mean, how we can implement stack and linked list with dynamic memory allocation. There are two ways to represent any concept, either static memory allocation or dynamic memory allocation. Static memory allocation means we have to implement with the help of the array, and for the dynamic memory allocation means we have to implement with the help of the linked list. So in this video we are going to discuss about dynamic memory implementation of stack and queue. Initially we are discussing about insert operation. Then further we will discuss about delete operation, because stack and queue are here implemented through the linked list, and these implementations are possible through insert operation and delete operation. Therefore, we are discussing about insert operation first. Insert operation we can implement via three ways. Number one, insert at beginning. Number two, insert at mid. Number third, insert at end. If we talk about the beginning operation, how we can insert at the beginning. At the top, linked list is defined, and this linked list consists of here three nodes. At the first node, value is here 48, and we want to insert the node before it, insert at beginning. So first of all, we have to create a node. Node should be created, and this new node should points to the previous first node. So in this way we can insert the node at the beginning. So we need here create a node here first, and say address of this node is assigned into the pointer. This pointer is q, and we need here q arrow next equals to head, because head contains address of the first node, previous first node. In this way now q becomes new first node. Therefore, we need to change the value of the head, and we are putting here head equals to q. So if we observe here in the second diagram, node number value 93 is here becomes first node. So in this way we can implement insert at the beginning, and this is the complete code for insert operation at the beginning. We are creating here linked list structure, linked list integer item part, struct linked list next part, and we have here three pointers. Pointers are here head, p and q, and we are making here a function insert at beginning, and in this function we are creating here node using the malloc function, and address of this node is assigned into the pointer. Pointer is q, and we are giving here value of item part using q arrow item. Then we are doing here q arrow next equals to head, because now this q is pointing to the first node, previous first node, and now head equals to q, because head always points to the first node. So we have here very simple code for insert operation at the beginning. Now we are discussing about insert at mid, and say here at the top further we have here three nodes. First node contains value 17, second node contains value 48, and third node contains value 142, and we want to insert the node at the mid. I mean, after 48 we want to insert the node. I mean, after second location we want to insert the node. How we can implement this insert operation? First of all, we have to create a node, and we are creating a node here malloc function. Through the malloc function node is created, and q pointer keeps the address of newly created node, and we have to keep the address of the just previous node. Say we want to insert the node after second node, so we have to keep the address of the second node, and pointer P is keeping the address of the second node. Now we have to do here, we have to point here newly created node should points to the previous third node, and previous second node address is assigned into the pointer P. Therefore, we need here Q arrow next equals to P arrow next. Reason is that P points contains address of the second node, and P arrow next means address of the third node, previous address of the third node. Therefore, Q arrow next means Q is here newly created node. Newly created node is pointing to the previous third node, and now linking is required between second node and new node. Second node address is contained in the pointer P. Therefore, we need here P arrow next equals to Q. I mean second node and new nodes are linked. Similarly, new node and previous third nodes are linked. So, in this way we can implement the concept insertion at mid. See, this is a detailed code for insertion at second node. Say we want to insert the node at the third location, then we need here a loop I equals to 1, I less than equals to n minus 1, I plus plus, and say value of n equals to 3. Then this loop executes one time. Initially P is pointing to the head, P is pointing to the first node, and this loop execute only one time. I mean P equals to P arrow next. Therefore, P contains address of the second node. This is our requirement. We need the address of the just previous node, and after it we have created a new node using the pointer Q using the malloc function, and we are giving the value of item part here, and next two lines are here used for the linking purpose. New node is pointing to the previous third node, and second node is pointing to the here new node. So, in this way we can implement the concept of insertion at mid, and after it we have the insert operation at end. Here say at the top we have here three nodes. First node contains value 48, second value is here 17, and third value is here 142. We want to insert at the end, I mean after the third node we want to insert the node. Procedure is here very simple. We want to create a here node first, and say newly created node, address of newly created node is assigned into the pointer. This pointer is here Q, and we need here address of the last node. Therefore, we have to find out the address of the last node, I mean address of the third node, because third node is the last node. After getting the address of the last node, we need here linking. Last node should points to the newly created node, and newly created node, next part of the newly created node should points to the null. So, in this way we can implement the concept of insertion operation at end. This is the detailed code. P equals to hat. Initially P is pointing to the first node, and P arrow next node equals to null. I mean we are getting here address of the last node from this loop, and after executing this loop again and again, P pointers contains address of the last node, and in the next line Q equals to struct node star malloc size of node. Q pointers contains address of the new node. We are giving the item part for the Q, and we need here linking P arrow next equals to Q, because P pointers is pointing to the address of the last node, and this last node is pointing to the new node, and the last part of the new node is here null. Next part of the new node is here null. So, in this way we are implementing the concept insertion at end. Now we have here delete from beginning. Delete from beginning is here very easy job. At the top diagram, we have here total 4 nodes. First value is 6, second value is 4, third value is 17, and the last value is 42. And we want to delete the first node. So for the deletion purpose, we can use the free function. We are using here code p equals to head. Now this p is pointing to the first node, and free p, I mean first node is freed. After it, second node becomes the first node. Therefore, head equals to head over next. I mean now head is pointing to the new node, I mean second node, and this second node becomes our now first node. So head is pointing to the node that has the value 4. In this way, we can implement the concept of delete from beginning. Now, this is the detailed code, and we are further made here linked list, and 3 pointers here we have delete beginning, p equals to head, and free p, head equals to head over next. So in this way, deletion is possible from beginning. And now we are discussing about delete from mid, how we can delete the item from the mid. Say at the top we have total here 3 nodes, values are here 1, 2, 3 respectively, and we want to delete here second node. Then we can delete using the free function, and further we need here proper linking. Say we want to delete here second node, and pointer q is pointing to the second node. So we need the address of the first node also, previous node also. Previous node of second one is the first node. Therefore, p contains address of the previous node, I mean p contains address of the first node. And now linking part is started, linking part is start. We need here proper linking now, and p, I mean first next part of the first node should points to the previous third node, and after pointing this we can delete second node using the free function. So this is the further very simple code for deletion purpose, delete from mid. And this is the here code, p equals to head, I equals to 1, I less than n minus 1, I plus plus, p equals to p arrow next. I mean using the pointer p, we have the address of the just previous node, and in this way q equals to p arrow next. We are keeping the address of the node of which we want to delete it. So q contains here say address of the second node, and this is the here linking part, p arrow next equals to q arrow next, and we have here free function free q. So in this way node is deleted, and this is the last delete operation, delete from and say we have here for the 2 diagrams. At the top we have here 4 nodes, and second diagram consists of here 3 nodes. And at the top we have total here 4 nodes, and we want to delete the last node. I mean we want to delete the node where value is 42. This is the 4th node, and we want to delete it. So further procedure is here very simple. We want to keep the address of the just previous node also, and we need here to maintain the address of the previous node into the pointer q, and now we may delete the here last node, and we need to set here q arrow next equals to null. So in this way we can delete the node from the end of the linked list. This is the code here, p equals to head, while p arrow node next not equals to null, q equals to p, p equals to p arrow next. So in this way p pointers contains address of the just previous node, and q arrow next equals to null. So, in this way we can delete the node from the end. Now, this is our actual question, how we can implement stack implementation using the linked list. So, initially we are discussing about the push operation. When we talk about the push operation, then this is the insert at beginning. Say at the top we have total here 3 nodes and we want to perform the push operation. So, push operation means insert at beginning. I mean, head represents here to the top, as top is the last inserted value. Top always points to the last value, because stack working is last in first out. The top always points to the last node, and here head is pointing to the last inserted node, and last inserted node we have implemented, we have inserted at the beginning. So, whenever we perform push operation in the linked list, we perform push operation in the stack using the linked list. So, we need here insert at beginning operation. Say we want to insert 5 node, we want to push 5 times, then we have to call insert at beginning 5 times. So, in this way we can implement the concept of push operation using the linked list. So, linked list is nothing but push operation using the linked list is nothing but this is the insert operation at the beginning that we have to call again and again. And now we have the pop operation. Pop operation is further delete from beginning. So, whatever we have inserted into the last, it should be removed first, last in first out. Therefore, we need here deletion from beginning, because head is always pointing to the last inserted node, and last inserted node is available at the beginning. So, we need here delete from beginning. So, in this way we can implement the delete from beginning, and this is equivalent to pop operation of the stack. So, if we want to delete say 4 items or 3 items, we need here to call pop operations 3 or 4 times. And this is the implementation of queue insert operation. So, insert operation of the queue is here. This is equivalent to insert at end, because queue works in first out manner. Whatever items we want to insert first, it will remove first. Say initially we have inserted here 48, then we have inserted here 17, then we have inserted here 142, then we have inserted here 93. So, insert at beginning, insert at end, and because head always points to the first node. In this way we can implement the concept of the insert at end. This is equivalent to insert operation of queue. And if you talk about the delete operation, as we have suggested, we have pointed out, delete operation of queue, the working of the queue is first in first out. So, whatever we have inserted first, it should be removed first. The first value is available at the first location, I mean head is pointing to the first node, whatever we have inserted at the first, head is pointing to it. So, we have to perform delete operation from the queue, delete from beginning. This is required for the delete to implement the delete operation of the queue. So, this is the detailed discussion how we can perform how we can implement stack and queue using the linked list. So, this is our conclusion. We need here insert operation and delete operation of the linked list to implement the concept of stack and queue using the linked list. So, we have discussed so many things about the implementation part, but if we talk about the equivalency, in here we are discussing about the head pointers, but in the stack we have here top, and if we talk about the queue, then we have here 2 ends, front and rear. but in the linked list we are using here only one pointer, and this pointer is called here head. So we have to make here proper equivalency. If we talk about the stack implementation, then head is equivalent to top, because top always points to the last inserted node, and same job here we are doing through the head. So head is just equivalent to top here in terms of the stack. When we talk about the queue data structure, then in the queue, as we know that we need here two pointers, two ends. Ends are here front and rear, but here we are using the concept of the head. So we need to change accordingly here, as we have discussed in the queue. If we talk about the insert operation, then we need to perform here insert at end, and if we are talking about the delete operation from the queue, this is delete from beginning. So we may choose here two pointers accordingly, and these pointers are here front and rear, and insert part is here at end of the linked list. So we can call here last node. We may choose here rear. Rear is pointing to the last node, and as we know that delete operation is performed from the beginning, from the front end. So we can use here head is equivalent to front. I mean, we may use here front equals to head, and address of the last node we may use here another pointer. This pointer is here rear. So using these pointers we can make here equivalency, and this is here very simple job. This is not a tough job. Actual part we have covered. And if we talk about the any data structure, this is the case we have discussed about the stack and queue. And if we talk about the case of the any data structure, implementation of any data structure, say if you are talking about the tree data structure or say graph data structure, then further implementation is possible through stack using the linked list or using the array. If our interest is in in the array implementation, then we can do. If our interest is in the linked list implementation of any data structure, then we can do. Totally depends upon our requirement. If our requirements are the static, then we have to use here array concept. If our requirements are dynamic, then we have to use the concept of the linked list. Array, static memory location and dynamic memory location has own advantages and disadvantages. If we know the size in advance, then we can use the concept of the array. If we don't know how many values may be there in future, then we need to use the concept of the linked list or dynamic memory allocation. So this is the summary, whether we have to use array or whether we have to use the linked list to implement any data structure. Thanking you.